Alright, so if you wanted to do the problems in part 5 using the integration by substitution, then you would just follow this example. So this is a way to write integration by substitution. It just says that we can rewrite a function of x product as a singular function of u, as long as we can find what du is. So like for example here we've got 6 times 4x minus 7 quantity raised to the negative 4. So if u was equal to 4x minus 7, well, first of all we can pull this 6 out front. So let's just think of that 6 as being out front. And then u can be equal to 4x minus 7. And then we can take the derivative of u with respect to x. And that equals 4. So we've got 6 integral we want it to be a u du, and that is to say we want it to be a function of u. And notice that if u is 4x minus 7, then this integral is the integral of u to the negative 4. But then to have a du here, we need to look at this piece here. So if I manipulate that by multiplying by dx on both sides, 4 dx is the same thing as du. So if I write du here, then that's like 4 dx. So it's kind of confusing, but excuse me. If I divide by 4 on a scalar and multiply by 4, then I haven't done anything to the original function. So that is to say, if I look back at the original function and I was to multiply by 4 and divide by 4, so put a 1/4 out here, put my 6 and my 4x minus 7 raised to the negative 4, and then put a 4 dx here, nothing's changed. So if I write it, because I've multiplied by 4 and I've divided by 4, that's basically doing nothing. But what it does is it lets me symbolically, now that I know what du is, that it's 4 dx, I can rewrite this as du, and then rewrite this as u to the negative 4, and then bring my 6 out front to get 6/4 the integral of u to the negative 4 du. So it's kind of tricky, but that's a way to rewrite this function as a singular function of u du. And then we just use the power rule. So the power rule here is to add 1 to the power. So we get negative 3, and then divide by negative 3. And that's all being multiplied by 6/4. So if you want to simplify that, that's 6 over, or negative 6 over 12, u to the 3, or negative 3. And that's negative 1/2 u to the negative 3. And then typically you want to write this in terms of x. So we undo the substitution, or that is to say we replace our u with 4x minus 7. So 4x minus 7 to the negative 3 times negative 1/2 is our antiderivative. And if they wanted the answer with positive powers, we would rewrite it as negative 1 over 4x minus 7 quantity to the 3. And there's always an understood c being added on. So the u substitution sort of recenters, maybe to some extent, the function. It's kind of tricky, but all of these should be doable. All of these problems in part 5 should be doable by a similar kind of substitution, because you can see that the derivative of each inner term is just a scalar in every case. Like, take the derivative of x plus 3, it's 1. That's the inner term here. Take the derivative of x minus 5, it's 1. Take the derivative of 2x plus 1, it's 2. All the way down to the last one, the derivative is negative 5. The derivative of the inner piece is negative 5. So each of these cases is an example of integration by substitution, where the du is sort of easy to set up. Alright, thanks.